Welcome to an introduction to circular bioeconomy by Spiridon Karitsas and Efthemia Alexopoulou. What is a circular economy? In the modern economy, resources are extracted from our planet, used to create goods and then discarded as waste. This linear process is consistent with a linear economic model. The foundation of this conventional linear economic model is the take, make, consume, throw away sequence. This concept depends on there being an extensive amount of readily available, cheap materials and energy. Planned obsolescence, the practice of designing a product with a short lifespan to entice users to buy it again, is another key part of this model. Societies have flourished thanks to this economic model, even if it has allowed the exponential exploitation of primary energy, i.e. fossil fuels, and our natural resources, i.e. raw materials. Mismanagement of these finite natural resources plays a crucial role in the linear model, burdening the natural environment and intensifying the crises related to pollution, biodiversity, and climate change. On the contrary, products and the materials they are made of are highly valued in a circular economy. The term circular economy has over 100 definitions, meaning different things to different people. Generally speaking, the circular economy can be defined as a new model for production and consumption that emphasises using less material, smarter design of products leading to the consumption of fewer resources, and recycling waste to generate new products and materials. In this manner, products and materials are circulated for as long as possible, eventually delivering societal benefits. The concept of a circular economy means that materials already used once are turned into valuable resources, thereby reducing waste production and encouraging the sustainable use of natural resources. Circular economy practices. The 10 leading circular economy practices are recover, recycle, repurpose, remanufacture, refurbish, repair, reuse, reduce, rethink, and refuse. These practices can be ranked in order of priority based on how circular they are. The first set of practices is smarter product manufacture and usage. For example, sharing a product. These are preferable to extending a product's lifetime because, for example, a single product might serve several consumers, a practice with high circularity. The second set of practices is lifetime extension, followed by useful application of materials, i.e. material recycling and recovery. In the third set of practices, in a circular economy, the lowest priority is given to recovering energy through incineration, since the materials are then unavailable for use in other products, a low circularity approach. Generally speaking, greater circularity results in greater environmental benefits. When materials in a product chain have a higher degree of circularity, they may be reused after a product is discarded, ideally maintaining its original quality and staying in the chain for an extended period. Examples of circular economy. We are surrounded by approaches which comprise circular economy practices. These practices may be used during different phases of a product's lifespan and in various industries, such as textiles, electronics, and construction. For example, practices in the textile industry encourage using regenerative agriculture to create organic cotton and other natural fibres. This guarantees safer and higher quality textiles that can last longer, be repaired, and be recycled. Reusing resources already in use, cutting back on the usage of virgin materials, or switching from carbon-intensive to regenerative materials like wood are some examples of circular practices in the construction sector. In a circular economy, animal waste is converted into biogas for heating, cooking and lighting, as well as being utilised as a natural fertiliser. Benefits of a circular economy. The circular economy is an approach to managing our limited natural resources while benefiting businesses, society, and the environment. It enables us to lessen greenhouse gas emissions, waste, energy and resource consumption, pollution, alteration of landscapes and habitats, and climate change and biodiversity loss. It empowers us to increase resilience, competitiveness, innovation, growth, and jobs. It also allows the reduction of risks related to price volatility, availability, and import dependency, while enhancing the security of the supply of raw materials. Additionally, consumers receive innovative and durable products that will improve their quality of life and ultimately save them money. The circular economy may also advance social justice regarding healthier communities, improved nutrition and well-being, greater food security, and green, decent and safe jobs. The shift to a circular economy is not without its difficulties though, since there are several issues related to multi-level governance, business models, consumer behaviour, finance, skills, and knowledge. What is a bioeconomy? The bioeconomy is a new model that uses biological resources to deliver goods, services, and processes across all economic sectors. It entails using sustainably renewable biological resources from the land and sea, such as crops, forests, fish and other animals, and microorganisms, for the knowledge-based production of food, bio-based products, and bioenergy. It uses the unrealised potential of millions of tonnes of residual materials and biological waste. Industrial, commercial or related service sectors that generate or process biomass, or which use biological resources, are collectively referred to as a bioeconomy. In particular, the sectors participating include agriculture, forestry, fishing and manufacturing of food, pulp and paper, as well as parts of the chemical, biotechnology and energy industries. The advancement of biotechnology, the efficient use of natural resources, and sectoral integration are the three primary components of a bioeconomy. In a bioeconomy, plants are broken down into their core components as much as possible and transformed into valuable products. It is anticipated that large biorefineries will use numerous coordinated process steps to perform this activity. There are 5 main arguments in favour of giving the bioeconomy considerable attention. The factors underlying these include developments in the biological sciences, a rise in trade within and across industries, in globalisation, and in the horizontal and vertical integration of agricultural supply chains, as well as advances in information and communications technologies. Benefits of the bioeconomy. The bioeconomy involves using biological resources to produce food, bio-based products and bioenergy, leading to economic, environmental and social benefits. The development of the bioeconomy is an opportunity to build an innovative economy that encourages sustainable development, modernise and strengthen the industrial base, creating new value chains and greener, more cost-effective industrial processes, accelerate progress towards a circular and low-carbon economy, stimulate employment, economic growth and competitiveness that are in line with the principles of sustainable development, reduce dependence on non-renewable resources, limit climate change and carbon emissions, protect the environment, biodiversity and natural resources, find solutions to societal challenges such as human health and livelihoods, food and energy security, food wastage and unsustainable consumption patterns. Processes and technologies in the bioeconomy. Process improvements that facilitate the effective use of residual and raw materials are needed to create a bio-based economy. The bioeconomic sector employs a wide range of techniques and procedures to achieve this. Their goal is to exploit residual materials and biogenic raw material resources through a coupled and cascading approach. The critical areas of attention are simple integrated chemical, physical and biotechnological or catalytic conversion technologies. The biorefinery concept is an innovative and promising way to replace oil with biomass as a raw material for producing fuels, electricity, heat and chemicals. Various biomass conversion methods and processes are integrated into biorefineries. Utilising biomass holistically to produce value-added intermediate products is the foundation of the biorefinery concept. Biorefineries therefore strive for zero-waste biomass usage by using efficient technologies to transform biomass into products and energy. Bio-based products. Products classified as bio-based can be obtained entirely or partly from biological resources. Materials that are fossilized or embedded in geological formations are not included. These products might be intermediate, material, semi-finished or final products. They are used in many industries and fields, including construction, furniture, chemicals, plastics, fertilizers and textiles. There are many different markets and applications: lubricants and functional fluids, adhesives, fibres, paper and packaging, fuel additives, landscaping materials, compost and fertilizer, plastics, paint and coatings, solvents and cleaners, sorbents, construction materials. These are a few examples of bio-based products. Benefits related to resource depletion and climate change are among the factors driving increased interest in bio-based products. Bio-based products have the potential to offer enhanced product functionality, reduced resource consumption during production, and optimal utilisation of all available natural resources. Bio-based products can assist in reducing carbon dioxide emissions, since they are made from renewable raw materials like plants. They can also have benefits such as lower toxicity or unique product qualities, like biodegradable plastic materials. However, compared to fossil-based products, bio-based products are often more costly, although it should be borne in mind the cost of fossil-based products does not take into account the resulting harm they do to ecosystems. Bioeconomy versus bio-based economy. Sometimes the terms bioeconomy and bio-based economy are used interchangeably. However, the production of biomass, including residual streams, and its use for non-food purposes, materials, chemicals and other bio-based processes, are the exclusive domains of the bio-based economy. Conversely, the production and use of food and feed, as well as the bio-based economy, are all included in the bioeconomy. Bio-based economy products can range from high-volume materials such as biopolymers, biofuels and fibres, to high value-added, often low-volume, fine chemicals like pharmaceuticals, cosmetics and food or feed additives. They can also consist of newly developed bio-based products like plant-based vaccines or new generation biofuels, as well as already existing ones like paper and pulp, detergents, lubricants and construction materials. Sustainable bioeconomy. The sustainability of the bioeconomy is a topic of continuous discussion. Just because the bioeconomy is reliant on renewable resources does not make it inherently sustainable. In fact, a non-sustainable bioeconomy may give rise to several sustainability issues. For instance, if the demand for biofuel rises, the need for biomass will also rise. This would create competition for arable land usage, freshwater use, and even food production, which might lead to social unrest or worries about social sustainability. Regarding the sustainability of the environment, such an increased demand for land to be used for biomass production would also have detrimental effects on the ecosystem. For example, indirect land use changes may result in increased greenhouse gas emissions. The bioeconomy still depends heavily on fossil fuels and non-renewable energy to produce raw materials such as polymers, organic compounds and nitrogen fertilizers, mostly from fossil-based oil and gas. Making a bioeconomy sustainable involves more than just replacing finite fossil fuels with biologically based renewable resources. The sustainable transformation of renewable bioresources into high-value bio-based products, materials and fuels needs low-carbon energy inputs, sustainable supply chains and promising innovative conversion technologies. The circular bioeconomy. The meeting point of these two new ideas, the circular economy and the bioeconomy, is known as the circular bioeconomy. Simply put, the circular bioeconomy is an economic model that integrates the ideas of the circular economy into the bioeconomy, emphasising more effective resource management of bio-based renewable resources. The circular bioeconomy is a framework that emphasises the sustainable development of renewable resources from land, fisheries and aquaculture, and their conversion into diverse bio-based products and bioenergy. It also transforms manufacturing and reduces reliance on natural resources. A circular bioeconomy is simply a more systematic use of bio-based renewable resources, utilising scientific methods and technological advancements to produce more sustainable materials and promote regeneration. Some benefits of a circular bioeconomy are better resource and eco-efficiency, less dependence on fossil fuels, reduced greenhouse gas emissions, and valorisation of side products and waste materials from various sources, including agro-industrial aquaculture and fisheries. In the end, the circular bioeconomy is more than just the bioeconomy or the circular economy alone. The two work in concert to create a more sustainable framework. The bio-based circular carbon economy. In practice, the circular bioeconomy is a bio-based circular carbon economy. The bio-based circular carbon economy enables us to take full advantage of atmospheric carbon, which is captured via photosynthesis. Consequently, a bio-based circular carbon economy presents a framework for improving circularity in economic systems. Using biogenic carbon for products and materials circulated in the same or better usage cycles closes the carbon cycle, with the potential for creating extra carbon sinks, filling the space between the circular economy and the bioeconomy. This creates new opportunities to meet net zero emission objectives in many sectors, particularly in the so-called hard to decarbonise industries like petrochemicals, by using biogenic or renewable carbon as the main structural component. Agriculture and the bioeconomy. All activities related to innovative production, utilisation and transformation of biological resources come under the bioeconomy sector. Therefore, this includes subsectors of agriculture, forestry, fishery, food, cellulose and paper production, as well as segments of the chemical, biotechnology and energy industries. Agriculture is one of the industries contributing significantly to the development of the bioeconomy, as it produces the majority of the biomass used as a raw material to make bioproducts. Agriculture is vital because it provides food while producing biomass, which is a significant source of renewable energy, bio-based products and bio-based raw materials. In the European Union, agriculture is the second largest sector of the bioeconomy in terms of turnover and employment, coming after only the food industry, including the production of food, beverages and tobacco. The bioeconomy, agriculture and sustainable development. Agriculture shapes cultural landscapes and is linked to the depletion of related products and ecosystem services, and the deterioration of soils and water resources. It causes more than 10% of the world's greenhouse gas emissions and a decline in biological diversity. Consequently, agriculture in the bioeconomy needs to be sustainable in the future. This means that agricultural production should be controlled to sustain biological diversity and ecosystem services, whilst also providing a rising population with an adequate supply of food and biomass. This is where agricultural biotechnology plays a critical role in addressing the issues of modern agricultural production. The bioeconomy presents new opportunities and challenges for farmers and rural communities. Farmer ownership in the new businesses is essential beyond just providing biomass. Producers of biomass, businesses, policymakers and researchers must all work together to create new value chains within the bioeconomy.